So we want to take a look at solving multi-step equations. So these are equations that are going to take more than one step in order to find a solution. Okay, so we're going to take a look at each of these examples and we're going to kind of look at how we can solve, and maybe we'll take a look at a couple doing it different ways. Okay, so first one, number one. So anytime you see a fraction, you want to think of that fraction as a quantity, right? A grouped quantity that we can't do anything with until everything outside of the fraction is kind of gone or on the other side of the equation. So before I deal with anything in that fraction, I want to get rid of this minus 3. When solving equations, we always use inverse operations. So if this is a minus 3, inverse to subtraction is addition. So I want to add 3 to both sides. All right. When we go ahead and add on the right, that adds to 0. So we say they cancel out sometimes, but really it's adding to 0. So we're left with x plus 4 divided by 6 equals 10. Okay. Now, anytime we have a fraction, our numerator is kind of either if it's alone, then we just have to get rid of the denominator first. And if it's a grouped quantity, we still have to get rid of the denominator first and then do a little bit more work to isolate our variable. But we can't do anything with the numerator until that denominator is gone. So right now, that denominator really is just dividing by 6. So the inverse of division is multiplication. So I'm going to multiply both sides by 6. 6 over 6 divides to 1, right? So we're left with x plus 4 on the left, and 10 times 6 is 60. All right, now we have a more standard equation that we're used to seeing and solving. X plus 4 equals 60. So I'm looking to find x, so I want to go ahead and get rid of that plus 4. Inverse of addition is subtraction, so we're going to subtract 4 from both sides, and we'll get that x equals 56. Okay. Next one. All right, so fraction is a quantity, right? So we can't do anything with that until we get rid of the 6. So the 6 is attached to that fraction with addition or subtraction, and it is a positive 6. So since it's positive and it's attached with addition or subtraction, we want to do the inverse. So since it's positive, that would be subtraction, right? So we're going to subtract 6 from both sides. So that adds to 0 there. And we're left with a negative. Now, when we have fractions, a negative symbol can be identified or can be assigned to either the numerator or the denominator, the top or the bottom. It doesn't matter. I default to wherever the actual constant number is. So I'm going to go ahead and put that negative with the 10. So I'm going to say that's x over a negative 10. It's just going to make our lives a little easier. And then over on the right, 8 minus 6 is 2. So now we have x divided by negative 10. Inverse of division is multiplication. So we're going to multiply both sides by a negative 10. All right. Negative 10 divided by negative 10 is just 1. So we're left with just x. 10 times 2 times negative 10 is a negative 20. All right. Last one. So this one I'm going to solve in 2 different ways. Okay. So I'm going to do it the probably easier way first, and then I'm going to do it the way that I probably see most people doing this. Okay, so whenever we have a fraction, we can get rid of that fraction by multiplying by its reciprocal, right? We can multiply by its reciprocal and get 1. So I'm going to multiply both sides by the reciprocal of this fraction out front. So I'm going to multiply both sides by 5/3. Okay, and the reason I'm doing this is because this is going to limit the number of times I have to deal with a number that is a fraction. Okay, so 5 over 5 cancels to 1, 3 over 3 cancels to 1, we're left with just that 2x plus 1 equals, and then using your calculator, or if you're comfortable with fractions, do it in your head, 6 times 5/3 is 10. So now I don't have to deal with any more fractions and I can just keep solving. So we're solving for x. So we always sort of work inverse PEMDAS when we don't have any fractions to deal with. So that means I'm looking for addition and subtraction first, or we can also think of working furthest away from x. So inverse, I'm going to subtract 1. That adds to 0. We're left with 2x equals 9. We're going to divide both sides by 2, and we're going to get x equals 9 halves. Anytime we get an answer that is a fraction or a decimal, we just want to leave it in its fraction form so that we get the most accurate answer, because sometimes we're going to get repeated decimals and we don't want to get into rounding. All right, so we're going to look at a second way to solve this. So same problem, 3/5 times 2x plus 1 equals 6. So the second way we could have done this is using distribution, okay? So a lot of times when we see a number outside of a parentheses, our first instinct is to distribute that number through. And we would get 6/5 x plus 3/5 equals 6. And you can already see now in the second step of this way versus the first way we did it, we have a lot more fractions and are going to be doing a lot more operations on fractions, but we're going to keep going with it. So we're going to subtract 3/5 from both sides. All right, so you're going to want to use your calculator for this, unless you're very comfortable with fractions. And we're going to get 6/5 x equals 27/5. All right, and then we're going to multiply by the reciprocal here. So 5/6 times 5/6. So cancels to 1, left with just x equals. And then we're going to go ahead and put those two fractions into our calculator as well. So 27/5 times 5/6, and you want to make sure that you reduce as far as possible. So that does reduce down to 9 halves. So we get the same answer either way. It's just looking at the right-hand side the second way. That's a lot messier than if we just got rid of our fraction to begin with by multiplying by the reciprocal.